Okay, as we all know, when we have n factorial, the typical definition for that is just n times n minus 1 times dot 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 up to 2 and 1. But this definition is unfortunately not so great because it only works for positive whole number n. What if you want to do more? It's okay because we have its extension. Namely, you can define n factorial to be either in terms of a gamma function or the pi function. One way or the other though, you will end up with the integral going from 0 to infinity. And then inside is t to the nth power, and then you multiply by e to the negative t dt. Well, if you're willing to take this as your definition, or maybe the extension of the factorial, then you can plug in 1/2 in it, and you end up with some crazy result. 1/2 factorial is equal to this integral, and it actually has a very nice answer, namely square root of pi over 2. Very good. I have a video on this already. Today, we'll do some other situations. Something similar to this. Alright, as you can see, this is just 1 times 2 times dot 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 up to n, yeah? So maybe let's look at this situation first. This right here is called the triangular numbers. I will just put down this as Tn. And this right here, by definition, is you just add them up. 1 plus 2 plus dot 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 up to n like this. Right? It's a pretty famous question, like Gauss, like 1 plus 2 plus 3 plus up to 100. 50-50 by the way. You end up with a nice formula for this. This is just n times n plus 1 over 2. Don't worry, I have the parentheses right here. Alright, so this is the triangular number, but it seems like this right here only works for positive whole number n again, right? Very similar to this. However, in this particular situation, we do have a very nice formula for that, and I'm actually not sure if people would like to plug in 1/2 into the n right here. If you think that's okay, leave a comment down below and I will do it right here for you guys. So if you put down t 1/2 like this, does that mean I can just plug in 1/2 into here and here? If you're willing to use this as your extension for your triangular numbers. So let me just see, 1/2 plus times 1/2 plus 1 like this, and then divided by 2. Work that out, you get 3 over 8. Crazy result, huh? In fact, you can do a lot more crazy things with this because, for example, if you take this and if you graph it, let me just put this down right here for you guys. You see, when n is equal to -1, you get 0. When n is equal to 0, you also get 0. And this is the open up parabola, so you actually end up with a graph like this, right? And if you integrate from here to here, -1 to 0, well, this right here, it's a famous number. Let me just put this down for you guys. If you integrate from -1 to 0 of this, you look at this as x, alright, please. Plus 1 over 2 dx. This right here will give you the famous result, namely 1 plus 2 plus 3 plus 4 plus 5 plus dot 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 up to infinity, namely -1 over 12. Well, anyway, yeah. Anyway though, so let me know what you guys think because I don't know if you guys like this too much or not. But it's okay, I want to do another one for you guys because this right here didn't really involve integral, because it does have a nice formula already. And I have shown you guys 5 ways to get this formula, okay? So if you guys would like, go ahead and check that out. Well, let's do the other version, which is actually much harder. So this is called the harmonic number, so Hn, right? Harmonic number, which is defined to be 1 plus 1/2 plus 1/3 plus dot dot dot, and then you end up at 1 over n, just like this. This right here, it actually has an integral extension for this as well, and that's exactly what I'm going to show you, alright? So let's see, how can we squeeze out an integral from here? It wasn't too easy for the integral for the n factorial. Well, thanks to Gauss and Euler, they did it, of course, they're genius. But for this one, if you think about it, you can actually work that out. It's not so bad. It's kind of like a power series, but it's not the infinite version. Alright, enough talking. Let's just get started. Alright, have a look. 1 is 1. 1/2 is equal to 1/2 times 1 squared, all right? Let me just do that on purpose. And then 1/3 is the same as 1/3, and then plus dot dot dot, and the last one is just 1/n, and then you should have x to the nth power. Well, sorry, 1 to the nth power, like that. All right, so this is what we have. And why did I bring this up? Have a look. This right here, we can put this as an integral by if you're thinking this backwards. In fact, I did a video on how you can get a sum by transferring a sum to an integral. You guys can try that question. It's very similar to this idea. All right, if you look at this backwards, you can see that this is just the integral going from 0 to 1. And what you will do is, this right here, you can just look at that as 1. Yeah, and then this right here, you can just say this is x plus, and then just x squared, and then plus dot 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 up to x to the n minus 1 power. And then dx that, please. Yeah. Well, why this? Have a look. Again, think backwards. If you differentiate this, you get precisely that, and you put that in the integral, of course, you get that back. So if you want to integrate this, for example, right here, you can just add 1 to the power, which is 3. Divided by 3, you get the 1/3. Later on, you will have to plug in 1, you get this. And you plug in 0, you get nothing. So this is how you can go from here to an integral like so, which is pretty good. And now, this right here is just the sum from 1 to x to the n minus 1. It's just like the best friend, but this is the finite version of it. I'll put this down. Hn, again, the harmonic number. If you would like, here is the integral extension for this, which is, which is just the integral going from 0 to 1, right? Going from 0 to 1. And then the inside here, you can put this down as a fraction, and then you get x to the n, right? If you end up with n minus 1, this is just x to the n, and then minus 1 over x minus 1, like so, right? So this is the integral extension of the harmonic number. And you might have seen this like putting it down backwards. It's okay, the negative, right? All that stuff. All right, if you're willing to use this as your extension for the harmonic number, let's plug in 1/2 and see what we get, yeah? So this right here is h sub 1/2. What's up 1/2? All right, anyway. This right here is just similar, like very similar to what we did with the 1/2 factorial. So all you have to do is put a 1/2 right here and then just work out the integral. So you have integral from 0 to 1. And then we have 1/2 here, and that's going to be square root, right? And then you have the x. And then this is minus 1, and then you have x minus 1, and then you have the dx like this. So that's pretty good. All right, now let's see, how can we integrate this? Actually, I don't know why I am not using a black pen, I'm sorry. All right, much better. So to integrate this, we can just do u sub. Let u equal to the top, namely square root of x minus 1, and add 1 on both sides, square both sides. We will get x is equal to, parentheses, u plus 1 squared. And then differentiate this, we get dx, that's equal to 2 u plus 1 du, right? So of course, we'll take this integral to the u world. We will see when x is equal to 0, put it here, we get 0 minus 1. So u starts at -1. When we put 1 right here, 1 minus 1, we get 0. And the top is precisely our u, so we just have that. And then the x is all that, so we'll put down u plus 1 squared, and then minus 1. And for the dx, we have all this, so let's put down 2 parentheses u plus 1 du. All right, to integrate this, it's not so bad. We can just do some algebra. All right, this is the integral from -1 to 0. We have 2u right here. Distribute that, we get 2u squared plus 2u. And then let's expand this. We will just get u squared plus 2 times this and that, which is just 2u. And then we also have the last term, namely plus 1. But we have a minus 1 here, so they cancel. So that's what we have. And as you can see, everybody has a u, so let's just cancel it out. So we have the integral going from -1 to 0, and we'll just have 2u plus 2 over u plus 2, like this. And now to integrate this, you can just do a long division first, or you can also look at the following. You see, if I double the bottom, we get 2u plus 4, right? But the top is only 2u plus 2. So that means I should add 2 here and then minus 2 after that. So all in all, you end up with the integral from -1 to 0. If you double it, you will end up with the 2 divided by the bottom, just the quotient 2. But you will also have to minus 2 and then divide it by the denominator like this. Integrate this. We get 2u, and then this right here will just give us minus 2 ln, and you don't need the absolute value because we know it's going from -2 to, it's going from -1 to 0, and the inside is just going to be u plus 2. So you can just do this, and then, of course, we plug in -1 and 0, the inside will be positive anyway. So now, have a look. When we put in 0, this right here is just 0, and then we have minus 2 ln. This right here is 0, so we have 2 right here. Yep. So that's the first part. And then we have to minus, put a minus 1 in here, so that's going to be -2. And if we put the minus 1 right here, minus 1 plus 2 is 1. Instead of the natural log, it's going to be 0, so we just have this right here. And all in all, that's what we have. So perhaps I'll put this in the front though. This is just going to be a positive 2, and then minus 2 ln 2. And ladies and gentlemen, if you want to have your harmonic number at the 1/2 term or so, the answer to that would be 2 minus 2 ln 2, which is a pretty crazy result. And again, integral did this again. Yeah? Every time it seems like you just use integrations to define something kind of weird. For example, the half derivative, the half integral, the half factorial, and maybe half whatever, I don't know.